I'll take the quiz and go. Okay. Did you guys notice how it's a nice wave, my background, how I did that? Yeah. So we're gonna finish talking about the sine function today. I hate graphing with a passion. This is the worst. And like I said, I know it's not a lot of people's favorite stuff, but we're gonna finish up 10B today. So yesterday, you guys should have talked about all of the basics for your sine function. So what's the period of a sine function? Like a normal, just y equals sine x. How long is that period before it starts repeating that shape? 2 pi. And so, how big is the amplitude of your general basic y equals sine of x? 1. So it should go up to 1 and down to 1 because where's the principal axis down the middle horizontally? 0. Right at 0. Okay, and so I think that was all of the basic stuff from your sine function. And actually, you guys, this does really look like a sine function, right? Because the sine function starts down, goes up, goes through 0, and then back to 0, right? I didn't even exactly plan it to be sine. I just thought it was a cool wave thing. And so we'll start talking about cosine next week after the ACT. But I always think about sine actually sort of makes like an S. Like to me, I sort of see an S happening, so that might be able to help you. Plus, on the back of your unit circles that we gave you guys, I don't have one. So on the back of your unit circle packet, it has this basic sine function for you. So you guys have this, and this is the first year we've handed this out, so I have to double check with Miss Crayons, but it kind of, gives you those basic numbers that were on there yesterday. It gives you the period, and it gives you like a little basic one, and actually all the quadrants. So that's there for you. So then yesterday you also should have talked about how if we multiply a number in front, that changes the amplitude, right? So that might make that amplitude more than 1, or it could be less than 1 as well. And then the really important other part was that if you multiply inside, it changes it horizontally, and it might squish that period in or stretch it out, right? So yesterday was the stretches. Today then, you guys already did your stat box, right? Okay. So then today are the translations. And so still from back in chapter 5, we did talk about the stretches, but in chapter 5, we also talked about the translations. So we can actually shift that principal axis up and down. It doesn't have to stay at 0. And then I think the horizontal translations, to me, are the most confusing part of shifting it over left and right. Okay, so first we'll talk about the easier piece of it, the vertical translation. So for the translations, that's when we add something to our function. Remember, if we're adding it outside of the function like it is here, y equals sine x plus d, that's going to shift it up or down. So normally our principal axis was at y equals 0 for our basic. When it's just y equals sine x, it's y equals 0. But if we're adding something, the principal axis will equal whatever it is we're adding. So if it's, y equals sine plus 6, that shifts our principal axis up to 6, or whatever that number happens to be. Did you guys use this graph paper yesterday? Anybody choose to? So I've got more of it. So I'm gonna graph it without on the board here coming up, but that's still an option if you want graph paper for your assignment. Are we ready for an example? It looks like some people might still be ready. Okay. So kind of with the same number I was using on the notes yesterday, I'm adding 4 to this function. So y equals sine of x plus 4. Now, if you use this graph paper, that wouldn't quite fit because this graph paper sort of has like 0 bolded, but you could write in different numbers on there as well. So what's going to happen then is it's going to shift 4 units up. So it's no longer going to be at 0, it's actually going to be at 4. So, normally I draw that in at 0, but we're not going to be at 0, we're going to be up at 4. So then I like to actually have my principal axis in there, so I'm just going to draw this dotted line for my principal axis. Do you guys remember what the numbers were that we put on the x-axis? Pi over 2. Yeah, we go all the way out to 4 pi. And you might have some that say 3 pi or 2 pi or something, so pay attention to your notes. I always kind of try to do it in halves. It helps me make it a little bit less random. So I kind of keep cutting it down in half. So now I've got pi, 2 pi, 3 pi, and 4 pi. And so then we'll put the pi over 2's in. The more you do it, the more you start to remember what these numbers are, right? You never forgot. And so the period and the amplitude are still the same. So we're still going to have one rotation of starting at our principal axis, going up, going down, back to the principal axis from 0 to 2 pi. Got like a really weird gap in here. It's a little bit not quite even. And then the amplitude is still the same as well. So are we ready to actually graph it? So instead of starting at 0 like we did on everything yesterday, we actually start at 4 because that's the principal axis. And then we end up going just up 1. So up 1 from 4 is 5. Then at pi, we're back down to the principal axis, which is 4. 3 pi over 2, we have to go down 1. Well, down 1 from 4 is 3. And then at 2 pi, we're back at the principal axis. So this is just like one cycle, one full piece of the sine curve. So then you can keep going. So we'll go back up to 4, down to 0, not 0, but down to 4, down all the way to 3, and then back up to 4. So it should look pretty similar to your curves from yesterday. It's just that principal axis shifted it up to 4 instead. But again, your amplitude is just 1 because A equals 1, and my period is still from 0 to 2 pi. You don't have to draw that blue stuff on there. I'm just trying to tie this into what you guys were supposed to talk about yesterday. Any questions or concerns? Okay. So then, when we add or subtract something inside the function, inside the parentheses, it's a horizontal translation then. So it'll shift left or right. But remember, it's like the opposite of like what you would think. Do you guys remember talking about that? Or we talked about it back in chapter 5. So if it's minus, it's actually going to move to the right. And if it's plus, it's actually going to move to the left. So just keep that in mind. I don't know if you want to write a little note for yourself or something. It's the same as chapter 5, though. It's not actually like new. Now, a lot of times you will notice that what's added or subtracted ends up being like in terms of pi, like you're adding pi or adding pi over 2. I, of course, had to be a little difficult, so we're going to be subtracting 4 to keep with that theme with the other examples, but we'll do one that's more like what you'll have in the note in the assignment as well. Okay, so then example 2 is going to be y equals sine of x minus 4. So again, since it's minus 4, it's actually going to move 4 units to the right. Yeah, okay. And see, sometimes I gotta slow down a second and think about it. Minus usually think about going left, but because it's the parentheses, it's opposite and all that. So instead of starting at 0 and then going up, down, and back to 0, we're gonna start over at 4. Now, the principal axis is still 0 because I'm not adding something outside the parentheses. It's still going to be 2 pi for our period, and our amplitude is still going to be 1. So then we can just, this is sort of, I think, how I showed most of them yesterday with 0, -1, and 1. Yeah, and it's going to be a little goofy, but I'm going to still just take us out to 4 pi, and we'll kind of go from there. So again, normally we start here at 0 and then go up and down and back up. But we have to shift over 4 units. Where's 4 on here? A little bit past pi, yeah. Because what's pi about? We know that's 3.14, right?
Oh, it's this.
Do you know what I'm saying? But I don't love this one either. I know I did do one of a little bit, doing the most for this example. Just stick with my theme. But you can always double check, like if I did 3 pi divided by 2, that's about 4.7. So it's going to be in between these two, about, probably about in the middle-ish. So because we've shifted over, everything is going to get shifted over. So usually then it's like, the next mark, but we're going to have to go in the middle. We'd be up to like 1. The middle again, about down to 0. The middle down to -1. And then again the middle. So that's about, 2 pi again for our period. Because we had to shift over 4. And that's about where 4 would be. And you can, kind of fill in the other blanks. So if I was going backwards, I'd be going down to -1. This is a really bad dot here. I feel like I need to fix that. There we go. And then, back up to 0 about here. So we can kind of work backwards and fill some more of that in. And we'd be about, up to there. So it looks very similar, but we did shift it over. Okay. Any questions? We still have just a couple more examples. We're going to do one more graphing one that combines both, and then just a couple of describing examples. Are you ready? So one thing that you might see, and it's a little out of order, is this vector notation. And so this is just saying, like, if we have y equals sine x minus c plus d, we can actually do the translation of both at once, like moving it left and right and moving it up and down by a vector. Now, technically, you guys talk about vectors in chapter 9 of geometry. So we usually talk about vectors in this class. It's in chapters 12 and 13, but we're kind of switching the curriculum a little bit, so you'll talk more about vectors next year in SL2. But a vector is just sort of like an arrow that's moving it left and right and up and down just at once. And so in geometry, you would see it noted like this. I don't know if that jogs your memory, but in geometry, we use like these like less than greater than signs. But in IB, they write it like that, which I don't love that notation, but you might see it like in your textbook. So just wanted to talk about that. But it's just saying it's moving it left and right and up and down all in like one swoop. Okay. So let's try graphing one where we have to do both things at once. So we're going to graph y equals sine of x plus pi over 2 minus 1. No, the outside stays the same as the inside. It's opposite. So this one's going to move us down 1. So then our principal axis will be at -1. That'll be like the line down the middle. And this is, instead of being plus, we think it's actually going to move us left. So it's going to move us left pi over 2. So here's the deal when we set this graph up. My principal axis is at -1, so I'm going to have to take my graph all the way down to -2. Keep in mind, there's nothing multiplying, so again, my amplitude hasn't changed. I'm still just going to go 1 above and 1 below our principal axis. So I'm going to sketch that principal axis in at -1. I guess I'm going to write these on top just because of the way this graph is set up. Someday I'm hoping I'll be able to draw a straight line up here, but it appears today's not that day yet. So again, we know we start at our principal axis, we go up, and then we go back down the principal axis, except normally I start here, but I'm shifted over pi over 2. So I didn't go into the negatives. We'll start going to the negatives more, I think, when we talk about cosine. But since normally I start here, but I'm shifted over, I actually end up starting at like the top. And then going down back to the principal axis, down to our minimum, back up to that principal axis, up to that maximum, principal axis, minimum, principal axis, and then back to maximum. So normally we start right here, we don't go up, but because I shifted over, that part's not even on my graph. It could have, but I didn't put the negative part on here. But we could have shown it, you know, it's off my screen, but down here and kind of coming back up. So we did two different things, moving it down to principal axis and then moving it left as well. Next, we're just going to talk about everything put together and just do some describing of graphs rather than actually graphing them. Are there any questions or concerns? Are you guys just feeling like this is like a ton of review?
Yeah.
Okay. Is it like a good review though, or is it like we didn't even need to have notes? Okay.
It's nice to have, it just could have been like a little shorter.
Shorter? Okay. Well, then maybe we don't need to do the last couple of examples. So this is straight out of your textbook, so if you don't have time to write this down right now, it is straight out of your textbook on page 242. But it just has all of the different parts. So we know that the A affects that amplitude, the B is the period, C is that horizontal translation, D is the vertical translation. So all of this is just like something if you're gonna study from, like I would study from this. And so again, maybe leave space in your notes if like copying it down out of your book will help you. But it really tells you everything you need to know with the principal axis, the period, and the amplitude. All right, so if we just describe these, okay, what's the 6 doing out front? How's that going to change our function? Maybe someone can just describe that for me. What do you got, Nick? Absolutely, the amplitude will be 6, so it's going to be not just 1 from the principal axis, but 6. And then what about minus pi? What's that going to do? Pi to the right. Yep, I did the wrong direction with my arm here. So pi units to the right. All right. Ooh, this one's tricky, I think. 2 being multiplied inside here. What's that going to affect? Or what? How you can describe the translation? Very good. So it affects the period, and I don't know if you guys heard, the period will be half as long. So remember, it's kind of the opposite of what's inside the parentheses. So instead of being times by 2, it's a horizontal stretch with a scale factor of 1/2. It'll be actually shrunk in.
Like divided instead.
Yep. And then what's the minus 3 do? Yep, y equals minus 3. So is it going to move it up or down? Down 3. All right, this was on yesterday's notes as well, but one more thing. Do you guys remember what what will happen if A is negative? It'll like flip it. So instead of going up first, it'll go down first. Yeah, we can talk about, well, not quite.
Not the same way that it.
Actually, cosines actually are horizontal translation of pile.
The way that the waves go, it would start out with toast.
But cosine is like, I'm not listening at all.
Yeah.
That comes here. You can have my clean one, KB. Not a word written. That's okay.
I've been talking about sweating on this.
Oh my gosh. When will this be due?
You can have my Monday.
After Monday. That's a
Wednesday, yeah. It'll be due the next class, well, 2 class periods from now, right? And so we will have, and then, are you guys going to be ready with B1 on Monday, or do you want me to check B1 and B2 together since I was gone? Together? All right, so then B1 and B2, we're just going to do 2 days from today. So we'll have class on Monday, so you can ask questions. I mean, technically you can ask the B1 questions today if you want, but we'll just put all the B's together. So then we don't have class on Tuesday because you guys have the ACT, so then these will be due on Wednesday, okay? We'll just do all the B's on Wednesday. If there's not, since I do need to do notes, if there's not time to check, we'll just won't stress about it. Is there a question about this, or? Okay. I would have to count them. I don't know off the top of my head.
Is it more than 2?